Hello everyone, I am Shilpa Bansal and in this video I'll take you through the basic concepts of finding remainders. This is the first part on the concept class of remainders where this concept is explained from scratch. Let us start with the definition of remainder. Dividend is divisor into quotient plus remainder. Remember you have studied this formula in your primary school. For example, if I divide 5 by 3, the quotient is 1 and the remainder would be 2. So according to the rule, the dividend, which is 5, is equal to divisor 3 into quotient 1. So 3 into 1 plus 2, 5. Now how important is this chapter for CAT? Remainders forms one of the most important chapters to be done thoroughly for the preparation for CAT. A majority of the students face problems in solving the different kinds of questions that come from this topic. So in this video, we have ensured that the different types of questions on remainders are covered. Now this is the first class where we will be covering 4 of the methods, and in another video we will be covering the remaining methods to find the remainders. So let's talk about the different methods to find remainders. First method, that is a pattern method. P plus Q plus R form method. P into Q into R form. Test of divisibility. Now remember, these are the basic rules or the basic formulas to find remainders. Now there are other rules which would be categorized as intermediate, a tougher one to find the remainders. They would be your remainder theorem, successive division method, a plus or minus b the whole raised to n form, and division by a prime number. So the remaining 4 we'll be discussing in another video. In today's video we'll be discussing the first 4 basic methods to find remainders. Now let us start with the pattern method. Now what is a remainder when 3 raised to 59 is divided by 6? So as per the name, it's pretty clear, the pattern method, right? So we can observe a pattern. So how can we do that? We start with a very lower power because 3 raised to 59 is a very huge number. Remember, it is not 3 into 59. It is your 3 is multiplied 59 times, which is a huge number. So here the question is find the remainder. So what we can do is try to take a very small power of your exponent. So let's start with a very small number, which is 3 raised to 1. So if I divide 3 raised to 1 divide by 6, I get the remainder as 3. Now let's take a higher power, 2. So that is 3 square, which is 9. 9 divided by 6, the remainder is correct, 3. Next let's move on to 3 raised to 3, which is 27. If I divide 27 by 6, I get 6 fours are 24. 27 minus 24, the remainder is 3 again. So is it clear that we are developing a pattern here? It is not always necessary that the pattern be the same number which is repeated. You can have a pattern of a number in a cycle of 2 or a cycle of 3 or a 4. So the only problem is you have to observe with some smaller power and come to a conclusion. So here I think we don't have to go to a higher power. Even if you go to 3 raised to 4, which is 81, even if I divide 81 by 6, I still get the remainder as 3. So can we straight away conclude that 3 raised to 59 on dividing by 6, our remainder would be 3. Okay, so let's move on to the next method, which is P plus Q plus R method. So when a number P plus Q plus R is divided by a number, let's call the divisor as A. Then the remainder is obtained by dividing each of the numbers by A. The sum of the remainders when again divided by A will give the final answer. So for example, if I have P plus Q plus R divided by A, if I divide P by A, I get my answer as AK1 plus R1, where R1 is the remainder obtained by dividing by A. Similarly, if I divide Q by A, I get an answer as AK2 plus R2. And similarly, if I divide R by A, I get the remainder R3. Okay, so can I write this numerator as A into some multiple K plus R1 plus R2 plus R3 divided by A? So the point is, instead of dividing the whole sum P plus Q plus R divided by A, rather we can divide each number by A and get a individual remainders. Then simply add the remainders and again divided by A. So that would be your final answer. That is R1 plus R2 plus R3. Now let's code an example to check whether you have understood this formula. So on your screen you have find the remainder when 323 plus 626 plus 939 is divided by 6. So as per the formula, we'll divide each of the numbers by 6. So if I divide 323 by 6, 6 5s are 30, 23, that is 6 3s are 18. I get the remainder as 5. Now I divide 626 by 6. 6 ones are 6, 6 fours are 24. So I get 26 minus 24. The remainder is 2. Now divide 939 by 6 again and I get the remainder 3. So as per the rule, now I'll add all the 3 remainders, which is 5 plus 2 plus 7. Sorry, 5 plus 2 plus 3. So which is 10. Right? So there's a mistake on the screen. So if I add 5 plus 2 plus 3, I get total sum as 10. And if I divide 10 by 6, the remainder which we'll get is 4. Okay, so the remainder in this case, that is, I got 5 plus 2 plus 3, which is 10. 10 divided by 6, the remainder is 4. There's a mistake, the answer is not 2, the answer would be 4. Now let's move on to the next rule, which is when a number is of the form of P into Q into R, and if it is divided by a number. So in this case, what we do is, let's call the divisor as A again. Then the remainder is obtained by dividing each of the numbers by A. The product of the remainders when again divided by A will give the final answer. So if P, Q, R is individually divided by A and the remainders obtained are R1, R2 and R3 with quotients as K1, K2 and K3, then again in this case, can we say rather than multiplying P into Q into R and then dividing by A, what we do is we divide individually each of this number by A and get a remainder. In this case, we are getting it as R1, R2, R3. So simply multiply R1, R2, R3 and divide it by A. So that's how you can get the remainder faster when you have a product. So let's take an example to check if you are clear with this method. So find the remainder when 23 into 43 into 48 is divided by 7. So divide individually each of the number by 7. So 23 when divided by 7 gives you the remainder 2. 43 when divided by 7 gives you the remainder 1. 48 when divided by 7 gives you the remainder 6. So multiply 2 into 1 into 6, which is 12. If I divide 12 by 7, I get the remainder as 5. Correct? So isn't it easy? Instead of multiplying 23 into 43 into 48, which is cumbersome, what we are doing is we are individually dividing the 3 numbers by 7 and straight away getting the answer. There's hardly any calculation here. So moving on to the next method, which is the divisibility method for remainders. So the divisibility method, the rule for 2. So if I have to divide a number by 2, what you can do is simply check the last digit, that is divide the last digit by 2. Whatever answer you get, that would be the remainder. For 3, the remainder for any number when divided by 3 can be obtained by dividing the sum of the digits of the number by 3. In case of 9 is a similar rule, that is add the digits. Right? The remainder for any number when divided by 9 can be obtained by dividing the sum of the digits by 9. For 4, just divide the last 2 digits by 4 and you can obtain the remainder, which is obvious because 100 is divisible by 4. So any number I just have to check for the last 2 digits. In case of 5, you just have to divide the last digit by 5. In case of 10, the remainder is your last digit. Moving on to the next one, which is your 8. So the remainder can be obtained by dividing the last 3 digits of the number by 8. Remember, 1000 is divisible by 8. So you just have to check the last 3 digits to find the remainder. In case of 16, we can generalize. Remember, in case of 4, it was last 2 digits. 8, last 3 digits. 16 is last 4 digit. So if I ask you 32, you will say it would be the last 5 digits. Anyway, for 100, yes, of course, it would be the last 2 digits. For 1000, yes, the last 3 digits you have to divide to get the answer. That is the remainder. And in case of 11, remember what we do is you take the numbers in the odd places, add them, and take the numbers in the even places, add them. The difference should be either 0 or divisible by 11. So let's take an example to understand whether you have clearly understood the divisibility rule. So here you have a question where you have to find the remainder when 1, 3, 6, 7, 8, 9 is divided by each of this number 2, 3, 4, 5, 6, 8, 9, 10, 11. Let's start with 2. So in case of 2, it's clear, right? You have to divide the last digit by 2. So 9 divided by 2, the remainder is 1. Now in case of 3, you have to add the digits, remember? Now rather than adding all the digits, why not we better cancel the multiples of 3? So here in this case, can I say I can cancel 3, I can cancel 6, I can cancel 9, in fact I can cancel 7 plus 8, right? So 7 plus 8 is also cancelled, which is 15. So can I simply say the remainder would be 1? So if I divide 1, 3, 6, 7, 8, 9 by 3, the remainder would be 1, correct? Next, divide by 4. So just divide the last two digits, which is 89. 89 divided by 4, the remainder is 1. For 5, just divide 9 by 5, last digit. So if I divide 9 by 5, the remainder is 4, correct? For 8, divide the last three digits, 7, 8, 9. Divide by 8. 8 6 are 72. 29 minus 24. The remainder is 5. For 9 is the same method what we have used for 3. Just cancel all multiples of 9. So 6 plus 3 is cancelled. 9 is cancelled. 8 plus 1 is also cancelled, right? That is also 9. So the remainder would be 7. Correct? Let's move on to 11. So in case of 11, what we do is add the odd places. So let's start with adding the odd places, which is 3 plus 7 plus 9, which is 19. Then add the even places, 1 plus 6 plus 8, which is 15. Now take the difference of the odd places and the even places, which is 4. And 4 is not divisible by 11. So this number is definitely not divisible by 11. Or you can say the remainder would be 4. Yep. So let's just quickly go through what all rules we have done in today's class. We have seen the basic formula, dividend is divisor into quotient plus remainder. We have seen a pattern method where you can straight away get the remainders by observing a certain pattern with the smaller powers of the exponential numbers. In P plus Q plus R form, we have seen we can individually divide each of the number by A and get the remainder. In P into Q into R form, what we do is we divide each of the number by A, multiply individual remainders and again divide by A to obtain the final remainder. Okay, before I close this class, just take some homework questions. These questions would help you to decide whether you have understood what has been taught in this class. So the first question is find the remainder when 3 raised to 59 is divided by 6. Second question, find the remainder when 5 raised to 1977 is divided by 1000. Next question, find the remainder when 333 added 15 times is divided by 7. Find the remainder when, yes, take down that number from the screen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 raised to 144 upon 729 raised to 48. So these are your homework questions. We will be discussing in another class the answers for these questions. They are simple questions which are based on the topics what we have covered in today's class. So that's all for today's class.